Welcome to this video tutorial on the Upstream Analyzer in NimbleThis PNM. In this video, we'll introduce you to the Upstream Analyzer and show you how to use this application to optimize your network's performance. Let's dive in. The Upstream Analyzer in NimbleThis PNM is a powerful tool that helps network operators analyze a return path, in particular, analyze ingress of their upstream spectrum. For NimbleThis Upstream Analyzer, we use a technology called Upstream Triggered Spectrum Capture, or UTSC, which is part of a Cablelabs DOCSIS 3.1 standard. The UTSC capability essentially acts like a spectrum analyzer for the cable network. It enables CMTSs or RPDs, or remote PHY, to analyze the upstream signals coming from the field. When a UTSC event is triggered, the CMTS or RPDs capture the RF spectrum from the cable plant, and then we can display it in a manner that's similar, if not identical, to spectrum analyzers. This spectrum analysis is often used for troubleshooting purposes to identify noise, interference, or other issues that are affecting the performance of the cable network, in particular cable modems. Let's see this in action in the NimbleThis PNM application. So when you're in the application itself, you simply navigate to the Upstream Analyzer menu right here. And then we have two different options. You can either select ports by the node name or the interface name. We find that most of our users generally like to select by the node name. So we'll simply type in node 1. We can select node 1 here. We get our node names directly from the CMTS, or we can import them by a flat file, or we can do a database migration in order to get our node names. Once you select the node name, the CMTS or RPD will be configured, and then we'll start streaming data to the web UI or also the mobile app. So you'll get a very similar display. In the mobile app, it's going to be a little bit smaller. At the top of the page, restart the analyzer. You can reset the analyzer traces. You can toggle color filling on and off, and you can start and stop the analyzer. Below, you can see data cards. The data cards for each analyzer contains the center frequency of the channel, the start and stop frequency of the channel, which also allows you to calculate the channel bandwidth. It gives you the channel identifier, the modulation for each channel. Next up are the total code words, the correctable code words, the uncorrectable code words for each channel, and then we also give those to you in a percentage, the percentage of correctable, the percentage of uncorrectable. Remember, we want to keep uncorrectables to under 1% to not impact users. And then we also give you the MER, the modulation error ratio, in dB for each channel. And so this is a channel from 5 to 20 megahertz, channel centered at 24.4 megahertz, from 22 to 26 megahertz, and so on. So these are what we call the channel data cards. At any time, you'll see these counters are incrementing. At any time, you can reset the traces just by hitting this reset analyzer, and that resets all your counters back to 0 and also resets your traces. An important feature of the data cards is that by clicking on a data card, it resets the counters and the traces, and then makes the area behind the data card. It highlights that in yellow, so you know that's the active data card. Amplitude per division and also the reference level can be adjusted for your optimal viewing pleasure. These are basically set by you. At the bottom of the screen, you'll see that you have the ability to look at correctables, uncorrectable, and MER for each channel. And you can turn these off. You can toggle off MER, you can turn off uncorrectables, and then you'll just be left with the correctable code words. In this laboratory environment, there's not a lot to see on correctables and uncorrectables right now. You can see your MER, and MER scale is on the right-hand side, whereas the code word errors is on the left-hand side. MER is on the right-hand side. One can easily zoom in on a portion of the spectrum just by clicking and zooming, and then we can just look at one haystack, and then a double click on the background will allow you to zoom out. The blue trace here is your max hold. We can turn our max hold off and on. The green trace underneath is your min hold. The yellow trace is your average hold. So that's your average power spectrum throughout the trace. The top here, and all of those can also be toggled off and on. So each one of these is toggleable. When you hover, you'll see that's your markers. So you can see I'm hovering here. That tells me the frequency that I'm hovering at. It also gives you your max, min, live trace, and the yellow is your average power trace we're seeing right here. You can see we're currently in mid-split. That takes us out to 85 megahertz. If I click on high split, that takes us out to 204 megahertz. You can see we have some noise ingress that's coming in, something we would want to deal with before we go and put maybe an OFDMA channel at the higher frequency, and then I can toggle back into mid-split and come back into 85 megahertz. So you can see how quickly it is to zoom in and out, and so that's about it. You now have a better understanding of how the Upstream Analyzer in Nimble PNM works and how it can help you optimize your network's performance just by having visibility in any noise impairments you may have, and then troubleshooting those noise impairments. So stay tuned for more video tutorials on Nimble PNM, and don't hesitate to reach out to our support team if you have any questions. Thanks for watching.